Hello, hello. Good. So thank you everyone for coming tonight. Thanks for braving the smoke and the heat, and we're just so glad that you're all here with us. We're gonna get started now, and I just wanted to tell you that I'm Cynthia Scott. I'm one of the 4 BeeChicas, and this is Deborah Foy, another one of the 4. So 2 out of 4 are here tonight. And we are so happy that you have joined us as we continue our BeeChicas speaker series, which is called BeeChicas Presents, Exploring Nature Nearby, Restoring Wonder and Connection. So thank you as always to the Boulder Public Library for making this possible. And also, thanks to Beth Conray. I think she's still out in the lobby. She is with People and Pollinators Action Network, PPAN. And if you haven't heard of PPAN, please stop by and talk to Beth, because it's a wonderful organization doing great work on state legislative issues that relate to bees. And sorry, I'm going to take my glasses. Can't see my notes. So the goal of our new speakers series is to engage you all with new and fascinating information that highlights how interconnected our natural world is. And we hope to inspire you to take positive actions, both big and small. So we've already been wowed by 2 award-winning conservation authors, Susan Twite and Ben Goldfarb, who reminded us that our ecosystem includes not only the plants, the insects, the birds, and the beavers, but also the humans, all of us, that live within the ecosystem. Tonight, we have the great pleasure of introducing the co-author of the BeeChicas' favorite go-to book on native bees, Dr. Olivia Messenger-Carril. The Bees in Your Backyard is the book that we always refer to, and it's a must-have guide for exploring the world of over 4,000 different kinds of bees in just in the United States alone. But did you know that there's over 1,000 species of bees in Colorado? And further, did you know that there's over 560 bees that are native to Boulder County alone? So we have a lot of them around us. Dr. Carril has her PhD in plant biology. In addition to teaching at the Santa Fe Girls School, she has also co-authored The Common Bees of Eastern North America, as well as her most recent book, which is up on the desk, The Common Bees of Western North America. A professed lifelong admirer of bees, Dr. Carril's love of nature was ignited when her parents gave her a plant press and a pair of binoculars and asked her to keep the family journal on their adventures. Her curious mind was engaged, and the rest is history. We love this quote from Olivia. "Studying bees allows me to sustain my childhood enthusiasm for nature, for mystery, and for exploration. My goal is to expand our understanding of who lives where and why. I love my job. I love that I'm doing my best work when I'm staring at some stunning flower, often one in a field of hundreds, in an area seldom seen by other humans. I love the sound of a bee teasing open the petals of a flower. I love that my job allows me to bring my young daughters with me and show them the wonders of being outside." Well, we couldn't agree more, and tonight I hope you'll join me in welcoming Dr. Olivia Messenger-Carril.
Can you hear me? Okay. That was my one job tonight, was to figure out how to turn that on. We got it. Hello, everybody. I'm so happy to be here and be talking about one of my favorite things with you. Thank you, BeeChicas, for the opportunity to be here. Thank you to the library for setting this up. Kathy, I don't know where you are, but thank you for that. And Amy and Ben, thanks for running everything back there. You've been super helpful. I've been studying bees for a really long time now. Every year that I give a talk about bees, I have to up the number, which is hard. But anyway, I've had a chance to explore bees in a lot of different places around the world, and mostly in the western United States. This year, I'm working in a couple really interesting areas, the Tonto National Forest, Yosemite. I'll talk about those a little bit. But everywhere I go, I kind of spend my time standing around with a net, staring at a flower and waiting to see what bees come to it. It's pretty exciting work, believe it or not. I know it looks boring, like I'm bored, but it can be very exciting, especially when the bees are few and far between. You have to work for them. I think I love my job most because I'm an ecologist, and I've taken lots of classes between my bachelor's and master's and PhD, and there's always these textbooks full of graphs, and there's an x-axis and a y, and so just something's happening. They can be a little abstract, but when you're out looking at a landscape and watching these things happen and watching the connections that you guys talked about happen right in front of you, it becomes very tangible. It's like the graph manifests in front of you. It's much easier to comprehend, which I like. Four of the big projects that I'm working on right now include a lot of long-term monitoring. So we have a lot of questions about how our bees are doing, which bees are doing well, which ones really need our help. And in order to do that, we have to understand sort of the baseline population dynamics for bees, and then we can see how those numbers are changing over time. So that requires going out and sampling the same place in the same way at the same time of year for multiple years in a row to figure out what natural variation looks like. Along with that, I'm helping the BLM design a monitoring strategy that they can apply to any piece of BLM land in the western United States, and there's a lot of those pieces of land, to get a sense for how bees respond to treatments that they might do, whether it's thinning or burning or restoration or taking care of sage grouse, all of these different things. They can add bee monitoring on top of that. In the state of New Mexico, where I live, in Santa Fe, I'm also studying 10 rare plants found throughout the state and trying to figure out what bees are pollinating those plants, with the goal of, my favorite part's actually the spider. See the little spider on the side who's just like, what is happening? Totally alarmed. If we can understand which bees are visiting these plants, then when they design sort of strategies for helping the plants, they can include the bees' needs as well, because obviously if the bees don't make it, the rare plant won't. I'm working in the Tonto National Forest doing a bee survey. The Tonto is amazing because it runs from 2,000 feet way up into the mountains. So we have this amazing elevational gradient. We're looking to see how bees change along that. And then I'm also working in Yosemite National Park. I have a crew of 5 people out there right now, all collecting bees above 10,000 feet. They're not allowed to collect below 10,000 feet. We're trying to get a sense of the alpine bee community there, because one of the things that we worry about is how bees at high elevations, which are more likely to be impacted by climate change, are going to fluctuate as those climate changes happen. One of the really cool add-ons to this is we'll have the ability to, we're going to build what we call a DNA barcode library. So we'll take DNA off of each of the bees after we've identified which species they are, and then use that DNA fingerprint, if you will, to be able to go back to these places and pick a flower off of a plant and then pull the DNA from that flower and figure out which bees visited it. So we won't have to lethally sample bees anymore. We can use the plants, just plucking one flower to figure out what's going on. That'll be really cool. It's a few years away till that actually happens, but we're headed there. And then I also spend a lot of time sharing my love for bees through books. I put this slide up. The books are out there, but I put it up because if you have bee questions and you want to ask them after tonight, maybe you forget, maybe you come up with a new one, please reach out to Joe and I. This is how you can find us. We love to talk about bees, both of us. When Joe and I started working together on writing The Bees in Your Backyard many years ago now, we both had sort of different angles that we were coming at to try and figure out what the reason for writing this book was. He was a beginning professor at Utah State University in one of their extension campuses. And he'd been asked to give a lot of sort of armchair naturalist sort of talks. People, he'd go to the Audubon and they mostly are learning about birds, but they'd want to learn a little about bees. And he realized there was this whole group of naturalists that were dying to know more, but that there was no resource available for them. At the same time, I was working on my PhD at Southern Illinois University, and I was in the plant biology department. But many of the students working in there were doing plant studies that involved figuring out how the plants were pollinated, and they didn't have any grasp of the bees, not because they didn't want to, there just wasn't a way, sort of something to get them in and get them started. And so on their final graphs, the best they could do would be to put, 2 bumblebees visited, 10 other bees, and 3 honeybees, and that's as other bees was, didn't sit well with me. So we wrote this book to try and help, and to kind of figure out, engage people in what they knew already about bees. We put out an online survey. We ended up getting about 1,400 responses, and we asked 3 questions. And so I'm going to phrase a bunch of my talk tonight around these 3 questions and how we can use it to know what we know about bees. So the first question we asked was how many bee species there are in the United States. And you all know the answer now. If you were listening, you should all have this. We actually left it open-ended, so it was a fill-in-the-blank. People could put 3 billion if they wanted, whatever number they wanted. But tonight, I'm just going to limit it. Here are your options. 50, this is the United States, just the U.S. 100, 850, 4,000, or 20,000. And I won't pick on you. Just think it in your head, and let's see how well you do here. So most of the people who participated in our survey thought there were fewer than 100, fewer than 50. In fact, most people put 20 or so in the little fill-in-the-blank, 20 bee species in the United States. Of course, the actual number is somewhere around 4,000, give or take. We don't know the actual answer because we're finding so many new bee species all the time, and the number tends to change every time we find a new one. Or we get a PhD student who takes a bunch of things we thought were separate species and lumps them all back together, and the number goes back down. But roughly that's where we're at. So worldwide, we think there's between 20,000 and 30,000 species. That's up there as far as like big orders of insects. You have grasshoppers and dragonflies and butterflies and things. This is a big group. There's 3,500 to 4,000 in the U.S., and I texted a lovely woman who lives here in Boulder to make sure on this number. She says the current count is 1,006 bee species for Colorado. So the number's going up. It used to be under 1,000, just under, and now you're over. So Virginia Scott's she's down. You should go meet her. She can tell you all about bees. So just for comparison, let me show you this. So a study was done, maybe 15 years ago now, where they took all of the bee records that they could find in museums and categorized them by state, and then lumped all of the states east of the Mississippi River together, and came up with the number for 770 bee species in all of those states in green combined together. So Colorado has more bee species than the entire eastern United States lumped together. And just so you can see how Colorado compares to other states, here's what we know now. And I will say this is changing constantly. It's almost always someone who points out a number that's gone up. So we're learning more. But generally speaking, what you see when you look at this is as you move from the eastern United States to the west, the bee species richness per state goes up. And as you move from north to south, bee species richness also goes up. So by the time you get to the southwest, I live in Santa Fe, New Mexico, Colorado, Utah, Arizona. Those are all states that have a lot of bee diversity. There's a lot going on there. California kind of wins. They have 1,600 bee species, but they also have the lowest elevations and the highest elevations in the lower 48. They have, interesting Mediterranean regions that you don't find anywhere else in the country, and it runs from Mexico almost all the way to Canada. So there's a big latitudinal gradient as well. So it kind of makes sense, I guess. Another interesting thing about this is that this pattern of a lot of bees in the desert, in this dry desert region, holds true around the world. Wherever the deserts are, wherever the drier countries are, we tend to find higher bee richness. Tropics, Not so much. Great place for beetles and butterflies and birds and all sorts of things, but not a great place to find lots of bee species. So the second question we asked was, what is a bee? So we asked people how many bees there were, and then we asked them, what is a bee? And so here I have 10 images. Some of you I know the answers to this. But some maybe, I don't know. Let's see. Let's go through this together here. So I'm going to shout out the number. When I do, if you think it's a bee, raise your hand. If it's not a bee, leave your hand down. So we're going to start with number 1. If you think it's a bee, go ahead and raise your hand. Okay. Number 2. Okay. Number 3. No looking at your neighbor. No cheating. Just kidding. Number 4. Okay. Number 5. Number 6. You have to pick. You can't go back and forth. It's one or the other. Number 7. Okay, 8, 9, 10. This young gentleman in the back knows his bees quite well. It's impressive. Here's the answer. You can test yourself. You can check how you did. Yeah, a lot of people think the number 9 is a bee. They get that one wrong. I should point out, too, that none of these are weird, rare bees. These are super common bees, absolutely here in Boulder, all over Colorado. You can find them from East Coast to West Coast. They are everywhere in the U.S. Actually looking at this, I would say these are some of the most abundant bees that we have. Number 9, sometimes people get thrown off by that one. Where I live, we call them velvet ants. It is a wasp. It's in the same order as bees, but it's not a bee. So this is how other participants did on our quiz, 1,400 people. You can see that generally people knew that bumblebees and honeybees and sweat bees were different kinds of bees. What's funny to me is those are the 3 that most likely sting people, and so we know them. We learned those ones. Down at the other end, most people knew that flies, butterflies, and grasshoppers are not a kind of bee. And then there's this weird category in the middle where some people knew and some didn't. Kind of threw us off just a little bit. So with that in mind, how is it that we know what a bee is? How do we define the thing that is a bee? We know we have things like honeybees, we have carpenter bees, we have bumblebees, we have mason bees, we have little fairy bees and sweat bees and squash bees. All of these are different kinds of bees. They come in all sorts of different colors. Can you guys see the rainbow? I tried to make it a rainbow. Red, orange, yellow, green, blue. It's almost purple. If you squint in the light, it's purple. We have bees that have polka dots and checkerboards and stripes. We have bees with smiley faces on their back. See a little smiley face? So what is it that brings all of these things together in this category that we're going to call the bee? If you look at the family tree for all of the different insects, right? So this is like a big tree that shows how different insects are related to each other. And the longer the branch, the longer the distance between 2 branches, the more distantly related they are. So branches that are close together represent insects that are closely related. And down here you can see this group, the Hymenoptera right there, has the wasps. It has ants in it, has all of the bees are in it, has sawflies, a couple other interesting things. And if we zoom in on just that one branch that says Hymenoptera there, it looks something like this. These are all the twigs, so these are all the little branches within that big one. And we can see that the group that we call bees all falls out together on one branch on this giant tree that is the bees, wasps, and ants. Which means all the bees are more closely related to each other than they are to anything else. But what it also shows is that bees are nested deep inside a tree that is mostly wasps. They're technically a kind of wasp. So bees are the wasps that have switched from eating meat and feeding their offspring meat to feeding their babies pollen. So they are the pollen collecting wasps is what they are. If we go back and kind of try and sleuth out what's going on here, it seems very likely that the first bee is something that we call solitary and was probably a specialist and only visited a couple different kinds of plants. And I'll talk about that here in a second. So let's compare a couple different kinds of bees. Can you see the 2 bees that are in this slide? There's 2 up there. There's one right up there. I just remembered I had a clicker. I think, does this have a pointer on it? Is it the lower one? Yeah. See it? Little tiny bee right here. It's on, this used to be called Cleome. I think it's called Paratoma now. What's the common name? Does anyone know? Yeah, that one. Yep. What's funny is this little teeny tiny bee here probably isn't pollinating this plant. It's probably kind of doing the plant a disservice more than anything because it's stealing the pollen off the anthers and not visiting the stigma, which is where all that pollen should go. So we have, and then over on this side, this is a honeybee. So there's two sort of big categories of bees in the United States, and I want to talk about them because a lot of people know this bee here quite well, this honeybee, and they don't know much about the wild bees and assume that honeybees and wild bees have similar characteristics. So we'll start here. We'll go through a couple things. So the honeybee is what we call semi-domesticated. Typically speaking, the word domesticated means that we probably benefit from having that animal in some way. But importantly, we're also in control of its reproduction. So we pick the mother and father and all of the little puppies or cats or horses or whatever comes out of it. So we call them domesticated for that reason. Honeybees fit all of the criteria except that we can't really control their breeding. We can't control who queen honeybees mate with. So we call them semi-domesticated. We've gone through lots of terms for all of the other bee species that are in North America. We're currently using the word wild, which I like because to me, it reminds me that I have 5 adorable chickens at home, very sweet. You can ask me their names later. And they are the equivalent of the honeybee. But then I also have a hummingbird feeder, I have bird feeders, I have turkey vultures that fly over, all these things. Those are the wild birds and the domesticated, and in the same way we have wild bees, right? So they're quite different. The honeybee is one species. There's only one species, Apis mellifera, in the United States. There's like 7 species around the world. All of the other bee species, those 3,500 in the US, are these wild bees. Most of the wild bees are what we call solitary. So in a honeybee colony, you'll find a queen bee whose job it is to stay home and lay all the eggs. That's all she does. And then her daughters spend all of their time taking care of her. All of those sisters will, they take care of her. They take care of the offspring that are growing. They go get pollen. They go get nectar. They look for new places to live if they need to move. They keep the nest clean, all of those things. And they divide up that labor so that different individuals have different jobs. With solitary bees, one individual gathers all the pollen and the nectar. She builds a nest. She puts all that pollen and nectar inside the nest with an egg that she lays. So she does all of those things. She keeps it clean and neat and does it all by herself. So they live in hives, whereas most of the bees, these wild bees, live in what I'll call single bee nests, right? There's just one bee that's in there. Honeybees, of course, make honey, and they do this because they're perennial. So a colony can last for many years. Queens can live for, I think it's 5 to 7 years. And so because they overwinter in that adult form, they need something to eat in the winter, and flowers are preserved. Honey is preserved flowers. It's just something to eat in the winter. I'll walk you through the life cycle for the wild bees, and you'll see why they don't actually need honey in the winter. And then honeybees, it's a memorable sting. It's hard to forget when you've been stung by them because they leave the sting behind. They're a little bit aggressive about it. Wild bees are less aggressive because if they die, they're done making offspring. Their life is over. And so are all of their progeny and everything coming behind. So their stings aren't barbed. It hurts, but not as bad as a honeybee, and they can sting you as many times as they want. Interestingly, only female bees can sting because the male bees don't have an ovipositor. A modified ovipositor is what the sting is, so male bees can't sting you. It's kind of fun. And then, of course, the honeybee is not native. It was brought over, people like to say it was brought over to the U.S. for sweetness and light. It was brought here for honey and wax products, whereas all of our wild bees, minus 60 introduced species, are native. So most of these wild bees nest in the ground. Here's a cute little one. This is called a chimney bee. She only visits globe mallow for pollen, and she's building a little nest here. She's using her mandibles. She's in the middle of a road. It's very hard packed, and she's using her mandibles to chew out a little hole. She's using her arms to press the walls into perfectly circular little things. She'll dump out any leftover dirt And then she'll put all of her little eggs inside there. So if you look inside these bee nests, you often find one main shaft, just like in a mine, and then these little sort of side tunnels, these side chutes, and each one of them will have sort of a little alcove that has pollen, an egg, and then she backfills it so that her offspring that are in there, that little egg when it hatches, grows up alone in a hole in the ground in the dark without any of its brothers or sisters around. A little bit different than the honeybee. Some of them leave you with the impression that perhaps they're very deep. People want to know how deep bee nests are. They range anywhere from, just a couple inches under the ground to maybe 1 or 2 feet. There are a few documented cases of bees nesting 9 to 15 feet under the ground. We don't know why, but we think they reuse the same nest entrance and just keep building on it with successive generations. And I put this in just because it's cute. It's adorable, little bee. Bees that don't nest in the ground, it's about 70% that are in the ground. They nest in wood. So here's a little leaf cutter bee. She's pulled off a piece of leaf. She chewed it, just snipped it off, perfect little hole punch piece of leaf, rolled it up, and she's taking it back to use as wallpaper inside her nest, which is in a piece of wood. They don't like to chew their own holes, so they find some sort of pre-existing cavity to use. This one's a mason bee, and rather than use it as wallpaper, she actually chewed it up and made like, what's plywood? Plywood, this is plywood right there, dividing each of those. So you can see there's pollen, and then she'll put an egg, and then a wall, pollen, egg, wall, pollen, egg, wall, pollen. Each of those is a separate little nursery for a baby bee to grow up in. So that's 1, 2, 3, 4. She has five offspring so far in there. You saw her do the little swimming's happening right now. That's the Katie Ledecky flip. Flipped over, dumped all the pollen off, and then she'll go get more and keep going. Something people ask me when they see this slide sometimes is, what happens when this egg, which clearly has a head start over all of the rest, what happens when this bee hatches, eats all its pollen, grows into an adult, and is ready to go, but its brothers and sisters in the rest of the nest aren't ready yet? What keeps it from chewing through and ruining all of mom's hard work? Bees have this amazing ability to pick the sex of their offspring. So a mom decides at the time that she lays an egg whether it'll be fertilized or not. She stores sperm from being mated inside her body, and as she lays an egg, she chooses whether to release sperm, and it'll be fertilized, or not, and it's an unfertilized egg. Fertilized eggs become females, and unfertilized eggs become males. So she puts all of the females at the back of the nest. They have twice as much genetic material. It takes longer to grow up. And then she puts males at the front, so the males hopefully leave the nest before the females are ready. Hopefully everyone's more or less timed out. Some bees, instead of using leaves, they'll use like cotton wool trichomes that they collect off of leaves to pad the nest. So here's a little wool carder bee. See the cotton ball? She'll take that back to the nest and use it to just make it just right. And then this is my current favorite. I mean, I change my mind all the time, but right now, this is my favorite. This is from a little bee related to the wool carder bee, and she'll take 60 to 70 trips and grab one pebble at a time and bring them all back to where she's going to build her nest on the outside of a rock. It's about that big. These are little. And there's 1 or 2 little nurseries inside there. And then she'll get sap from trees or like the gum underneath gumweed. You know, you've seen how sticky that plant is. They can scrape that off and they'll use it to glue the pebbles together and create these little structures that she has her offspring in. Many of these bees are what we call specialists. The fancy word's oligolectic, which means that even when they have lots of plants that they could be gathering pollen to feed to their offspring, this is specifically for their babies, they limit themselves to some subset of what's out there. So maybe it's just all the cactus flowers, maybe it's all the sunflowers, maybe it's bigger and it's everything in the sunflower family, the Asteraceae. It depends entirely on the bee species, how narrowly specialized they are. But no matter where you find that bee in its range, or no matter which generation you're looking at, they always specialize on that same plant. It's kind of fascinating. Other bees are a little more generalist, so they'll go to anything that's out there, sort of a smorgasbord of what's available. No matter what, they're happy. And so that leads to a situation something like this. You get your specialists and your generalists all hanging out in the same garden together. A bee's life cycle is about 1 year total, from egg laying until the next year at that same time of year. It lasts about 1 year. So let me walk you through sort of what that looks like. I'm showing this as an early spring bee, but it's important to remember in your mind that we could take that entire year that starts in the early spring and shift it so that it starts in the summer or maybe a fall bee and shift it again. So let's imagine for a minute an early spring mining bee comes out. The males, of course, come out first, like we talked about earlier, and they immediately start searching for the females and trying to find her. And when they do find her, they mate with her, and then she hangs on to that sperm. But her job is just to forage, collect as much pollen as she can, get it into a nest that she's built, and provide for as many offspring as possible. Survival of the fittest has in it the term fit, which means the most fit individual is the one that lays the most, or that produces the most offspring that grow up to also produce offspring. So the more eggs she can lay that make it to adulthood, the more fit she is. But here's the interesting thing. By summer, say early summer, about 2 months, 6 to 8 weeks after she came out of the nest, she's dead. She's gone. Her adult portion that we spend so much time looking at, that I write books about, all of that stuff happens in a 2-month period. The rest of the life of a bee is spent in the nest, which is probably in the ground, growing from egg through several larval stages and a pupal stage into next year's adults when they emerge and start the cycle over again. Many of them even go through a phase that looks a lot like a caterpillar, and that they'll spin a cocoon and go through a metamorphosis inside the cocoon before they come out. There's tons of variations on this cycle. It's not always exactly like this. Some bees can wait an extra year if they don't like the conditions that they feel in the soil as they're getting ready to emerge. They can wait 1, 2, up to 7 years for the perfect year to come up out of the ground. Some of them do this extra fast, especially if it's really warm outside. They may do early spring to summer and then real quick do a second generation that then overwinters. So lots of variation, but this is the general idea. Okay, so that's the natural history and overview of the bees. So now we're going to go on to the third question that we asked in our survey. Remember back to that. And we said on a scale of 1 to 5, how important are these bees? So you've already asked, how many different kinds of bees are there? What does a bee look like? How important are these? That was it. That was the whole entire questionnaire that we asked. So if 5 is super important, and I promise not to judge, I can barely see you. So you could hold up one finger and I wouldn't even know. How important do you think they are? What do you think? I hear it. I hear the 5s. Okay. 99% of people agreed with you. So even though they don't know what a bee looks like, they don't know how many there are, they don't know anything about the bee, they know they're important. We all somehow kind of know this. So let's talk about why these bees might be important. I can think of 3 things that I'm going to highlight tonight. The first one is that they're important because they feed us. All of the most colorful foods that we eat come from pollination with bees. I think Einstein said it best. If bees disappeared off the surface of the globe, man would have only 4 years to live. He didn't actually say this at all. But but his concept, or whoever attributed that to Einstein, he's not wrong, and neither is the guy that attributed this to Lincoln. Neither are wrong. You shouldn't believe these things, but it is true. So typically speaking, if you think about the diet that you had today, you probably ate bread, you probably ate pasta, some rice, all of those main sort of starchy things that you eat. They're not bee pollinated. Most of them are wind pollinated. And if the bees went away, we could still have boring, plain spaghetti with salt. Salt's a rock. We could put salt on it. We could have rice, boring, plain rice. We can have those things. And that's something like 70% of our diet is based around those things. So it's only about 30% that we'd really be losing. But what's interesting, and there's several papers very recently that have sort of hit on this, is how many vitamins and minerals we would lose by losing that last little bit. All of those colorful things provide a lot of the basis for our overall health. We can't actually live on hamburger buns and spaghetti, even if my 9-year-old wishes we could. So to really emphasize this, imagine for a minute that I have a chef's hat on and I am here giving you your menu for Carril Cafe. It's a lovely cafe that I just opened with all of these delicious foods on it. We have some appetizers, we have salads and soups, we have sandwiches, some entrees, and some desserts. And let's imagine this menu without bees. I also want to preface by making it very clear that bees are not the only pollinator, right? Hoverflies are very good. Flower flies are really good pollinators. Wasps can do a lot. Butterflies, moths, all of these things are important. So it's not just the bees. It's just that because bees visit flowers so quickly and efficiently, because their fitness is tied to how many flowers they can hit in a day, they tend to do the bulk of the pollinating, right? So it still happens without. It's just that everything on the menu becomes more expensive because the bees aren't making so many of them that we can buy them at cheaper prices. So we'll start here with the appetizers. If bees went away, guys, salsa would be gone. Every single ingredient in salsa is bee pollinated. So you have to take that off the table. What else do we have to get rid of down here? Down here in the salads and soups, we'd have to get rid of all of the spices. A lot of those spices and herbs that we like so much would go away. Kale, of course, cucumbers are out the window. Our BLT, most of the L and the T are gone. Our barbecue pulled chicken wrap, not doing so good on some of these things. All of the stuff that really sort of amps up our food and makes it tasty would disappear. So maybe we'd have a new menu. And pretty much every pie that I love would be gone. No salsa, no pie. I don't know how I'd live. It would be very different. So here we have a new menu. Okay, it works. But we're not done. Remember, too, that bees, believe it or not, are responsible for most of most of our dairy, because dairy cows require alfalfa, and alfalfa is absolutely bee pollinated. Not even by honeybees, mind you, which is kind of interesting. So we need to take out all of the cheeses that are cow-based cheeses. So now our menu is something like this. For sandwiches, we have a bee. We have a pulled chicken wrap. We have a porterhouse lamb chops. We have a shrimp. We got shrimp. I wonder, too, how chickens would do, because they actually scratch quite a few bee larvae out of the ground and eat them, so I'm not sure. I might change a little bit. Anyway, point being, our menus would look a lot different. A second reason that bees are important is because they don't only feed us, they're kind of the base of the food web, these connections for so many other things, whether it's the goldfinches that are eating the sunflower seeds in my yard after the longhorned bees have visited and done all of the pollinating, or whether it's the blackberries and blueberries and raspberries that the bears are eating to get themselves ready for winter, that are all pollinated by bumblebees and mason bees and other things that are out there. They do very much provide the base of the food webs in pretty much every functioning ecosystem in the world, around the world. And finally, a last thing, bees are important because they connect things. So this is really cool. A couple of years ago, I was asked by someone who works for open spaces here in Boulder to create a network that shows how bees and plants, based on some data that he had, are connected together. And we made this. In reality, it's interactive, so you can pick one and it shows all the links and everything fades out, which is really neat. But just to show that not only is it that they're creating the base of the food web, the other really cool thing that they do is connect everything together. So a bumblebee that visits first a gumweed and then over to a helianthus connects those two plants together through its visits. And if the bee went away, the relationships between those plants change in terms of who's doing the pollinating and all of that. It's kind of a big deal. And I want to talk about, we're going to come back to this idea of connections here in just a second. So now let's talk about, we have these amazing bees that are really important to us, but here we are living in a city, none of those natural habitats that I showed you where I'm doing my work. And cities maybe aren't so good for bees. It seems like a place where maybe there's some problems. Cities are growing quickly over time. We're removing habitat where bees could nest every time we put in a paved road. What's to say we're not damaging our bees by sitting here in a library, having taken away whatever natural space they're on? Well, interestingly enough, there's a bunch of research coming out to suggest that there are things that cities can offer to our wild bees that maybe aren't so bad. Maybe we're actually able to help them. We can think of bees as sort of our pet project. These are things that we can do to sort of help them, and it's really not that hard because all bees need is the Airbnb. It's pretty simple. They need something to eat and a place to live, bed and breakfast, super simple. So here's the cool thing about cities. A lot of the work that I've been doing in northern New Mexico has been taking place in habitats that look something like this. This is a natural area visited heavily by cattle, but other than that, there's not much else that's influencing this particular piece of land, except for the fact that we're in a mega drought and rainfall levels are severely reduced from what they were even 2,000 years ago. So this is the plot in 1 year. This is the exact same place the next year. Same time of year and everything. So cities are interesting because even when natural landscapes have this sort of ebb and flow in terms of how much rainfall is out there, our cities are more consistent. We're providing a stable place because we always water, no matter what. Even if we're watering less frequently, we're still watering more than the areas around our houses where nature is sort of taking its natural course. So more predictable water, which can be turned into more floral resources. In addition, especially compared to agricultural areas, people are finding that there are less pesticides happening in cities. Obviously, natural areas, even less. Generally speaking, there are exceptions. And what's more, and really interesting, is there's some research out of St. Louis, Missouri, showing that more affluent neighborhoods actually spray more pesticides because they can afford to sort of really take care of their neighborhoods, and they trim and they mow a lot and all of those things, and bee diversity is down there compared to places where people aren't taking care of their lawns quite as much. Either way, both have less pesticides than agricultural areas nearby. There's also greater floral diversity, technically speaking, compared to the monocultures of agricultural areas that might be nearby, unless someone's doing extra work to sort of do restoration on the side. So greater floral diversity, the question is, can we educate people to plant things that are of high quality for the bees? But generally speaking, there's more floral resources there. And then there may be more nesting habitat. Certainly if you live in the east, anyone been back east? And we have created so much nesting habitat for the eastern carpenter bee there, it's ridiculous. They're very happy that people live there. But that probably is true for other bee species as well that benefit not just from the bee houses that we put in, but also from all the wood products that we bring. Are the bees that we find in cities the same as bees that we might find elsewhere? Yes and no. We do see some subtle differences. Cities seem to filter out certain kinds of bees. Smaller bees, which are more susceptible to habitat fragmentation, tend to drop out in cities. We've seen this by looking at, I did a study in Red Butte Gardens, which is in Utah outside of Salt Lake. And even though the county, Salt Lake County, has a lot of a teeny tiny bee called a fairy bee, that's actually one of them right there. Even though there's a lot in the county, in the gardens, we found 2 species. So I think that's an area where that particular bee has failed to persist because it's too fragmented of a habitat. We also find that generalists are more common than specialists in urban areas. Probably has something to do with what floral resources are available and what people are planting. A lot of the things that specialist bees like to visit, people consider weedy plants. That's part of why specialists are on them, because they're very successful plants. And so the specialist bees, no matter what, can be on them, but a lot of people see them as weeds. And then, of course, our ground nesting bees, which require areas that aren't paved or treated or have weed barrier in them or any of those things, are lower in there. We also find more non-native bee species in urban areas, which is kind of interesting. This is the wool carder bee. It's absolutely here. It's a really big, really blatant, easy to see yellow and black bee that's flying right now, actually. This is its favorite time of year. You'll see them hovering in front of a lot of the plants in your garden. And this one just showed up in Colorado. This is Megachile sculpturalis. It's been in the east for a while, and it looks like it's made its way to Colorado now. And we find these more often in city environments compared to natural areas. So what can we do in cities to help with these bees? It's not much. It's just some simple things. Start with providing resources. Planting a garden. It's pretty simple. This is my mom's yard in Salt Lake City, Utah. She's in Sandy, and she's surrounded by neighborhood and beautifully mown Kentucky bluegrass lawns. And then she did this, and the neighbors were horrified. But what's really cool is I studied a bee that's a specialist on cactus flowers, and she has a patch that's cactus. And the year after she put those cactus in, I was able to study a diadasia population on the cactus flowers in her front yard, which made lunch break really lovely. It doesn't take much to encourage a lot of really interesting and diverse bees in cities, just planting the right stuff. And then, of course, connect those gardens. Habitat fragmentation is a really big deal, and it's important to think about whether your beautiful garden that you've put is existing in isolation or whether you're providing for it to go to other places. This becomes especially important in cities where heat island effects are happening, because in warmer places, bees tend to grow up in their nests faster, and when they grow up faster, they're smaller, which means they're more susceptible to habitat fragmentation because they can't fly as far. So the same species in a city is smaller than that bee out in a natural area. Connections matter a lot in cities. And then the final thing, and I really love that bees remind me constantly of the importance of connections. Everything is connected, and bees show us that all the time. We need to connect the people, all of the people that visit these places and want to learn about bees and learn to appreciate what we have. Those connections lead to these giant efforts to do the right thing by bees. So connect not just the bees to the plants, but connect ourselves. I think bees are sort of the gateway bug. They're super easy to wrap your mind around, at a very basic level. They're easy to see. They're fun to watch. They look like flying teddy bears. I mean, what's not to love? These are a perfect way for people to get the concept that connections are important, because every time you see a bee, it's on a plant. You're watching a connection, which I think is really cool. We humans have been worshiping bees for a really, really long time. There are stories in almost every culture of different ways that we have worshiped bees, whether it's Egyptians, the sun god Ra cried tears that landed on the sand and became bees. The word Melissa comes from an old Mycenaean word because that was the goddess that they had, and it means bee also. The stories that go with worshiping bees are older than our understanding of what a wild bee is, which is kind of amazing. But now is our chance to take this to the next level and add from our worship and our appreciation for them a little bit of knowledge so that we can actually do things to help the bees, to help the flowers, to help the base of these food webs, and sort of connect everything together. I'll quit there and answer any questions if there's anything I forgot to talk about. Thank you. You can try yelling. Do you want to yell? Yeah, and this is a great question that we think about when it comes to the science of bees a lot, because disconnection means something different depending on the bee. A bee that's a specialist experiences disconnection different than a bee that's a generalist, experiences it different, a large bee versus a small bee, a cavity nester versus a ground nester. All of those bees experience it. So quantifying that for a bee community is really tricky and is best done for different suites, different guilds of bees. And so that's been done quite a bit in the East, and it has to do with figuring out the words are alpha and beta diversity and where you see the turnover. So how would I say? So looking for turnover in communities of bees across time and how quickly that turnover happens gives us a sense for how connected or disconnected a place is. Does that make sense, the idea? So if you guys are all here and I can count you and say this is the group here, and then I go to Denver and it's a totally different group of people, that's disconnected. If you same people show up, if I'm giving a bee talk down there, I would consider that community still connected. So you can do the same thing with bees in terms of looking at which species are in different areas and measuring it. I think that's how we quantify it anyway.
So, could you give any tips on how to observe bees? Because I'm so interested and I go out and it's just such a struggle to really, I mean, generally I can see, okay, that's some kind of bumblebee or that's some kind of carpenter bee, and that's about it. Like how?
Do you, are you a bird watcher at all?
Yeah.
Okay, and so remember back when you started bird watching and you were like, that's a red one and that's a yellow one. And that was as far as you could get. It takes time and practice and looking at them over and over, and then you're like, wait, that one's only out this time of year, and this one's only on this flower, and this one's really big and fuzzy. So it takes research. There's a lot of really good online resources now. There's more and more good books. There's some that are like storybooks that kind of tell the story of these different natural histories of these different bees, and then some that are more sort of guides that show you how to look at them. There's a lot of classes you can take. There's a lot of YouTube videos now that are kind of getting into that you could do too. But for me, I think most of the learning about bees that I've done in the field has just been visiting the same place, standing in the same spot with my cup of coffee or beer at the end of the day, whatever it is, and watching the bees and seeing. So as an example, 2 weeks ago, I forgot to bring my garbage down to the end of the driveway, and so at 8 o'clock at night I suddenly remembered, and I'm heading down. The sun's down, it's kind of dusk out, and at the end of my driveway is this kind of weedy plant that never looks like it's open, and it was open. It was so weird, and it's apparently called a blazing star. Menzelia is the genus, and it opens at like 3 in the afternoon. Here's the cool part about the blazing star. At 3 in the afternoon, there's little tiny fairy bees, these tiny little bees that look almost like gnats, and they were all over it. After the sun had gone down, as I'm taking my garbage down, I stood there and watched them forever. And then a bumblebee came in after the sun was down, and I learned something new about bees in my yard just by looking. Yeah. I'll come back there, Lex. I have 10 questions. 10! Okay. 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 Got it.
So you were talking about how the difference between like richness of bees. So do richness of the bees correlate with the richness of plants? So in other words, if there's 535 bee species in Ohio and we have 1,000 bee species here, do we have more plant richness?
We actually do have more plant richness, so yes, they do tend to correlate in a couple ways, and it can be tricky. This is a complicated question. Yes, generally speaking, the more plant species, the more bee species. Flowering plant species, so that's kind of a key. And what we find is when we get to tropical areas, the kind of plants that support bees are fewer, and we wonder if that might be part of the reason there are fewer bees in tropical environments. There's more plants, but the kinds that bees visit are reduced. So yes, sort of. We do find that in, say, Colorado, in a year that's a drought and there's less flowers, there are less bees, and in a year that there's more flowers, there's more bees. And people have made beautiful graphs that kind of show how those two things oscillate together. But the weird part about it is, it's always been tricky for me as a bee collector, is that when there are more flowers, it's harder to catch a bee because they're all spread around this huge resource. When there's only one plant, everyone's on it, and I swing once and I've got all these bees, and then it looks like they're not correlated. So you have to weight it according to the floral richness, which can be tricky and make it hard to measure exactly. But generally speaking, yes, the more flowers, more flowering species, the more bee species. Yeah.
Yeah, so I was wondering, it's kind of hard to articulate this. But basically I know, like, we have native bees and we have introduced bees, and there are flowers that are really good for the native bees, and then flowers that are good for the introduced bees. And I'm wondering, like, if, there's, like, a type of flower that's good for both. Like, is it
Yeah. So most of the non-native bees that I know about visit native plants and seem to do very well on those resources. They don't tend to pick between them. And on top of that, a lot of the native bees, the wild bees, will very happily switch from whatever native plant they have evolved with for the last 30 million years. Boop, they'll hop right over on the invasive plant and be just as happy, which is really annoying, and leads to great seed set in that invasive, and it takes off and spreads, and it can be really hard. And it disconnects the whole connectedness network that you try to build. So I think the presumption that native bees are on native plants and non-natives on non-native isn't quite how it plays out. So in that case, it can be tricky to try and plant to just encourage one or the other. I think a lot of it in cities, and I think this is true, so you should double check me to be sure, but I feel like when I look at what's invasive, or I should say non-native, many of them are not invasive, they're just not native. I think most of them are cavity nesters. I think a lot of them made their way over in like a log or a piece of wood or something that someone brought from Europe or Japan or whatever. And it might have more to do with nesting habitat availability than the flowers that are out. Yeah. Yeah. I'm going to go here and then I'll come back.
I was curious if the native bees are also threatened by, like, varroa mites, which are such a threat to them.
No, varroa mites do not visit most our wild bees for a number of reasons, but no. There are other threats to the wild bees, but varroa mites is not one of them.
What are the other threats?
There's a couple of viruses, pathogens that affect bumblebees that are spread because they're kind of social and they live together. Some of them have come over, I think from Japan or Russia. It's a virus that came over that way. And I think another from Europe, now that I think about it. With our wild bees that are not bumblebees, that are solitary, it doesn't tend to be pathogens so much that are spread in the same way we can spread a cold around. It's more chalk brood, so it's more like fungal infections, other parasitoids that impact them, maybe a surplus of parasitic insects, other predators, changes in those things that really get them. Roads, climate change, lack of flowers, heat. Yeah, big landscape changes. Number 2.
There's all this work being done in Colorado, noticing how at higher elevations the bumblebees are moving up higher and higher.
Yeah.
And there's that discrepancy when flowers bloom and then bees come to technology.
Yeah.
Do you anticipate something like that happening throughout the United States, that we're going to start? Like, I noticed that in Montana they had less bee species than in Colorado, but do you anticipate as things warm up and heat across the globe that we're going to start seeing our native bee populations move further north in general?
I think about this all the time, and all I can do is guess. So I'll tell you my guesses. None of these are backed up by anything other than me going, Let's see. So, yeah, I have always thought, wow, so if climate change happens, that would just mean that this would be great for all of our desert bees, and Montana and Idaho would be wonderful places now. That probably depends. I think one of the factors that would impact that is how quickly bees and flowers move up to these new places. And if climate change happens faster than their ability to move to the new place, maybe it's not so good. That could be not so good. Deserts are super species rich around the world. Bees seem able to handle the heat really well. The thing that tends to sort of drop their abundance during the day is when nectar dries up in flowers. Then they go home because it's too dry and you don't see them out. And then when the nectar's back, the flow's back up, they're back out there. So maybe something to do with that could also matter. I was thinking this just last week, that maybe we have it wrong. I've spent all this time thinking about how, the deserts are these places that we should worry about. What if it's like eastern forests where bees are most likely to experience great change? Because a lot of those bees are adapted to that particular environment. And if that changes a lot, maybe it's those bees that are more likely to experience changes in where they live and how they live. Yeah, and I don't know. It's just a maybe. I wonder. I don't know. We don't know. I will say, we are experiencing amazing changes with the climate. Bees, they've been around for almost 120 million years. They've been here a long time. They've seen lots of climate changes before, and they come and go. There's probably always going to be winners and losers, and I would expect that with whatever happens in the future, we'll find the same here. There will be certain bees that are well adapted to whatever changes happen, and some that, like bumblebees, that might not handle it as well. Yeah. How harmful are herbicides? I think it depends a little on the bee species. So leaf cutter bees that literally line their nurseries with treated material may be more susceptible than a squash bee that doesn't really interact with those things. I have looked for papers and haven't yet found someone who's given a quantifiable answer on that, but it is something that a lot of researchers, actually a few in Ohio right now, are trying to answer, especially with bees that use plant material treated with herbicides in their nests. So stay tuned. We should have an answer in the next 5 to 10 years. It was a master's student, so I expect less than 10 years. Should be 5 years. Did you? You were ready. You're wondering how far they'll forage? It depends. This is biology, you guys. Everything depends. There's exceptions to all the rules, and everything depends. So I'll start every answer with that, but it depends on the distance between the two little covers on the wings. It's called the intertegular distance, and the smaller it is, the less the distance the bee travels. They found bumblebees, I think even honeybees will travel a remarkably greater distance than you would think for their size. But bumblebees tend to fly farther than most bees, and I think it's something like up to 6 miles tops that they've found. But most bees, their entire life, especially those little fairy bees, is in something less than the size of this room, really little areas. Yeah.
So I'm in central Denver, and the gardening group in my area, which is devastated by Japanese beetles, is advocating spraying like Dr. Bonners in water. And I'm like, I think that would affect the bees as well. So I just wondered if that is indeed true, that spraying a low soap solution on plants.
Oh, it's soap? Dr. Bonner's is soap? Oh, I was just going to ask what it was. Okay. Why does that affect the beetles?
I don't think it really does.
Because
So all the people in the gardening, I have not tried it. All the people in the gardening group are like, it works. I'm like,
Huh. So two things I would say of all the things we could spray, that's probably not that bad. I doubt it's going to do much. It'll depend somewhat on when it's sprayed. So if you were to spray it in the evening, so it sits for 18 hours before the bees are out, I doubt it'd have any impact at all, honestly. Yeah, I don't think the soap would bother them. I might be totally wrong on that. If you have enough soap, I use soap to sample bees in these little traps that are about this big, and I use soap because it acts as a surfactant, breaks the surface tension, the bees fall in. But that's a pretty high dose that I use. So I think diluted in water, I don't know. I don't have an answer, but my gut says it might not be that bad. Spray in the evening. That would help.
Could you talk about some of the things that we can do to provide more habitat, since we are, some of us are in urban, some semi-urban and rural, and for cavity nesters, and is it important that the straws or something be a certain depth as well as ground nesters?
So I haven't seen what all you have here yet. So you'll probably be like, yeah, I'm already doing all those things. So if you want to provide for the cavity nesters, sort of rotting logs can be great with little nooks and crannies, and let them find their own way into it and use it. Putting wood kind of So it's resting on the ground. They'll nest right at the base where the two pieces meet. You can also put in little bee hotels, bee houses, where you drill or use straws. And when you do that, you should make sure that they are, and this is based on the mason bee's size, and mason bees are about that big. So smaller bees might not need as much, but we haven't studied them because we don't use them in agriculture. But for those bees, it should be 6 to 8 inches minimum. Don't go any shorter than that, because I think the way this works is the bee, the female, walks into the nest kind of counting her steps. And if she doesn't walk very far, she lays an egg that becomes a male. And if she walks a long ways, she lays an egg that becomes a female. So shorter ones, we find that the mason bees lay only male eggs, like male bees. So having them a little deeper is important if you want both males and females in your gardens. And since females typically are the better pollinators, it seems like a good idea. So yes, providing habitat in that sense, sort of disturbed earth is great. Any sort of mound of dirt that you've put in. Trails are great. Bees love to nest on the edges of trails, whether it's trails that cattle have made or humans. They don't mind disturbance. Bees are quite happy when things are disturbed. They love wildfires, you guys. How weird is that? But then as far as flowers, I think the season that a lot of people miss is that early season when not much is going, and having something for those early mining bees, those early digger bees, can be really great to have. So a lot of those are shrubs, things like ribes, rus, what's the yellow one? What is it? Forsythia. Great for bees. Mahonia is lovely. That's also a really good one. I don't know common names very well. Mahonia? Anyone? Oregon grape. Yeah, those ones that bloom really early can be great for bees that come out early. I think the fall season kind of takes care of itself because we end up with all those fall composites, and that's a great resource for bees. I think I was talking to someone who had this beautiful yard she'd set up for bees. She lives south of Santa Fe. Very well cultivated, lots of natives, but she'd taken out things like globe mallow and false hoary aster because they looked weedy. I was like, ugh. But they do look weedy, I get it, but they're so great for the bees. So leaving sections that look a little wild is maybe something folks can do. And then talk to your neighbors, find out who's nearby, and see if they want to throw some plants down too. Give them a gift. Here, I brought you this plant. Put it outside. Yeah. Mm.
Have there been any studies on the impact of landscaping stones on
I haven't seen one. That doesn't mean there's not. I should look to see, because I expect I'll be asked that question again at some point. I have looked for mulch. Mulch is typically, if it's that thick, deep stuff, can be really hard for bees. And gravel, sweat bees tend not to mind gravel. There's a study out of Utah State University where they looked at people who use gravel to sort of landscape, and the bees would go through the gravel down to the earth and nest, and seemed to be okay. I wonder about the heat that might add. I'm curious, but they were doing it.
It's not just the heat, okay, underneath the stone is landscaping fabric.
That's always not good. That's so hard for bees.
Stone gets, I'm not talking about the mining, which destroys landscape,
Mm.
but when the stone is put there, it looks wonderfully. However, there's a lot of dust falling in, the
Yeah.
leaves are falling in. So how do you keep plants from growing in there? You constantly have to spray it with herbicide.
Yeah.
And we have neighbors, and I can, it's like, regularly, the old man come out,
Yeah.
the young guys come out, they do it professionally, and they spray all of the river rock, otherwise, plants, grass, whatever.
Comes up through it. Yeah.
Going to start
Right.
growing very quickly.
Yep.
So, it's actually kind of a scourge.
That sounds, yeah. I had never thought about the angle of you have to have the weed barrier not in there.
Like a great concept as long as I just read and heard about it when
Yeah.
Eastern Kansas. And after moving here and having done our own yard and seeing what it entails, it's just a horrible thing, actually.
Ah.
You were talking about the heat.
What about ground cover? Why don't people plant like low growing thyme or Straussea coccinea, that low?
It's a cultural thing.
Yeah, that's what has to change. That's what has to change. Yeah, for sure.
I think it's probably when people moved from the countryside more to the suburbs, they developed this concept of being on top of nature and not having to fight it right when they work on the farm. And
Well, we probably brought with us from the East, you know, some of these concepts about what it takes to control the area around your house. I remember moving to Illinois for my PhD, and everyone had these giant mowed lawns. I was like, what is the point of this? This is so much time on a lawnmower. This is ridiculous. It's big enough you have to ride a lawnmower to do this. It's not, anyway. And then I found out in my own yard that if I left it pretty quick, I had chiggers, I had poison ivy, I had more ticks and more mosquitoes, and I couldn't go outside. I understood why someone might want to push nature back a little from the house. I had never thought about it, and maybe we brought that culture with us, this like push it back a little, even though maybe we don't have to here. We're lucky. We're lucky you're here. You have a question?
So earlier you mentioned that bees spreading like wildfire. So I was wondering, do bees have any adaptations to deal with like extreme conditions, or like as right now there are multiple wildfires in Colorado?
Yeah. These are the questions all the master's students are working on right now. They're good questions. There's a bunch of people in Fort Collins that are trying to find answers to these. You guys ask the questions that we don't have answers to yet. Should all go get a master's degree. Probably they do. So, for example, the little tiny fairy bees that we know don't nest very deep in the earth, we tend not to find in areas that experience frequent fire intervals. They tend to be more desert bees, and before we had cheatgrass that kind of connected that and changed the fire regime, those areas didn't burn very often, and nesting shallow was absolutely not a problem. So there might be some sort of thing happening there. A lot of the cavity nesting bees that we see in the mountainous regions that burn tend to nest near riparian areas, and a lot of the hollow stems for plants, think ribes, rosa, rus, all of these things, sambucus, that grow near really wet areas often have cavity nesting bees. And I've wondered if that's not that's where you're going to survive when a fire comes through, because it's slightly wetter. You're more likely to than if you're nesting in something out in the middle of the ponderosa or mixed conifer. So that might be an adaptation. And then Jim Kane out of Utah State University took bees in their little cocoons, so bees that were nesting in the ground, and put them inside coffee cans with dirt, and stuck them in there, and then submerged the coffee cans in water and heated the water to different temperatures to test for mortality and figure out how hot you could get bees before they perished in their larval forms, and found that they can actually, the heat that comes from a wildfire, a natural, not these ones where they linger and literally burn the soil off, bees can survive those, no problem. Mortality was pretty low. It was actually pretty low. Now, the fires we're getting now, two things. When we go through, and one of the ways that they'll thin and treat an area is to create this mulch layer. They'll kind of chop it all up into fine debris, and then when the fire hits that, it actually is a little hotter, and maybe that's not as good for the bees underneath because that's an unnatural heat. And then some of these fires, as they move through, because of how much understory is there that hasn't seen a burn in so long, are burning hotter than they naturally would, and that might not be good. But it seems like bees have some adaptations. That was a long answer. I'm sorry. I really went off there. Yeah. It's a low-growing thyme. It's a species of thyme. Yeah. Don't walk barefoot on it in the summer because the bees are all over it. Yeah. No, they love it. They love it. Yeah. It's a good one. She never has to mow it, and it required very little water in Salt Lake. Yeah.
So we see a lot of bees around here. So there's that whole idea about do we grow cultivars? Does everything have to be native? And
Yeah.
there's a lot of work being done at Penn State on that.
Yeah. Yeah.
But I've got a very specific question about lavender.
Okay.
So we see bees all over, right?
Yeah.
In this part of Colorado, and in urban areas, there's lots of lavender covered with bees. I'm not so convinced they're pollinating though.
I'm not either. I don't know. I have Joe, my co-author, is actually in France right now studying bees on lavender. I wish he were here. Let's call him. Let's see what he has to say. Yeah, totally could.
They're so covered in, and in the areas I see them, there are a lot of native plants. They've got other choices. There's bee balm and there's liatris and there's a lot
Yeah.
of stuff, but they're really going on that.
Who's on it? Do you know enough about bee? Is it mostly honeybees or is it other stuff too?
Oh, no, I didn't see, well.
Oh, nice.
We do visit them,
Mhm.
but in these particular sites I'm talking about, we didn't see any honeybees. So we saw bumblebees, mason bees, serratina. We
Nice.
even saw some perdita.
Cool.
All large to tiny.
So I have, again, this is all in my head, and I'm probably should shut up. Here's my idea. Here's an interesting idea for you. I think that some of those plants, what they're producing that the bees love, is tons of nectar when everything else is kind of shut down. And it's often mint flowers, which have this shape that kind of shades the nectaries. And I'm wondering if they're just not like drinking fountains with Gatorade pouring out of them, and the bees are loving it. And that's why the bees are on them, is for the nectar, and it has nothing to do with pollen. Yeah, that's...
It looks like when you watch them, because you don't really see, you don't see any carbiculate full of
Yeah.
pollen.
No.
You don't see anybody carrying pollen. And then just one more quick question
Uh-huh.
on that, sort of same thing, is when I'm watching the bees in native habitats in urban areas, so I'm talking about dense urban areas.
Okay.
It seems like the tiny bees are not really visiting the center of the flower, they're just there to rob the pollen.
Absolutely. Yeah, they are. No, bees are, we think, and I didn't say it tonight, maybe I should have, just a reminder, bees and flowers love and hate each other at the same time. They love the thing the other does for them, but at the same time, every bit of pollen that a bee grabs off the plant and takes back to the nest is reduced fitness for the plant. They're making less offspring when the bee is successful. And vice versa, if the bee doesn't get any pollen, the plant's successful, but the bee is not. So there are so many ways that bees and flowers manipulate each other in order to get what they want without having to give up too much. And one of the things that those tiny bees often do is take pollen and not really do, and then they fly away and they're not really good pollinators. Not all bees are great pollinators. Some people think male bees might be better pollinators than females just because the pollen ends up all over their body and they don't tuck it away in the scopal hairs and hide it and make it harder to drop off on a stigma somewhere. They also visit less efficiently, so there's a trade-off there. The females are faster and moving more, so hard to say. But yeah, you're right to notice that, and it's true. They're not all good pollinators. They're still great. They're still wonderful.
Well, fascinating talk. We could go on forever and ever. I think we'll have to cut it off. Olivia will be in the front signing her books, and you can buy books and posters and pamphlets, and so take a look there. And I also just wanted to let everyone know, if you don't know about the Bee Boulder Festival that happens every year during Pollinator Appreciation Month, which is the month of September here in Boulder, we are having our 10th anniversary of the Bee Boulder Festival, celebrating habitat, biodiversity, and bees, of course. And so that's on the last Saturday of September, and you're all welcome to come and bring your whole family. And Oh, yes, it's here in Central Park in downtown Boulder next to the farmer's market. So a lot of action is happening. So, but thank you so much. What a wonderful presentation.